Okay, so let's start. And just a reminder, we'll have a test tomorrow. Everybody knows this, right? So test tomorrow. So can you all take out the notebook? And last time we stopped at discuss the order in which we discussed the order in which metals are discovered. So this, if you look closely, you will find that it has in the order in which metals are discovered, there's something to do with the reactivity of the metal. So what conclusion can we draw from here? Yeah, when the metal is discovered, how is it related to the reactivity? So the earlier the metal is discovered and used, is it the higher or the lower the reactivity? What can you say about the metal that is first used and the metal that we only recently learned how to extract? Iron. Iron and copper, which one is more reactive? Iron. So therefore, what can we say? What conclusion can we draw? Yeah, the earlier the metal is utilized or extracted, the lower its reactivity. Can you put down this conclusion down at the bottom? So the conclusion here is that, right, this. Okay, so the earlier a metal is discovered and used, the less reactive the metal. Yeah, because we only have limited technology, okay, at the beginning. So we can only extract very unreactive metals, but not the very reactive ones. So the less reactive the metal, and the easier the extraction. So the easier the extraction. So we will now look at the more complicated part of the metal chapter. It's the reaction part. Okay, so what metal react with? Okay, and what are the products that are produced in each case? So on the new page, okay, so this will take up quite some space. Yeah, on the new page, I wanted to look at the reaction. Yeah, so here the reactions of metal. Yeah, in relation to their position on the metal reactivity series. So first, I want you to, if you can copy this once more. But if you cannot, then just write down the symbols. Okay, so just write down the symbols. And we have in here, you see these different metals of different reactivity, and they can all react with, well, some of them can react with oxygen, some of them with water, some of them with acid. So can you create three, titles here? Okay, so the first one being the reaction with oxygen. The second one being the reaction with water, and the last one being the reaction with acid. So we have reaction with oxygen, reaction with water, and finally we have reaction with acid. So these are the three main things, remember? We say that metals react with. But the reactivity tells you that not all the metals can react with these three substances equally well. For example, gold doesn't react with any of those substances. So gold has no reaction with oxygen, so it stays shiny. Gold does not react with water, so it will remain unreacted when you draw in the water, or ordinary acids. Okay, so starting with you see oxygen, so you can maybe split it this way. So we have. So let me just copy this first, okay, and let me string it down to it. For reaction with oxygen, the first few metals up to iron. So up to iron, also special burden, so up to iron, they react and they will burn. Okay, so you will see a flame. So that's what react and burn mean. Okay, but starting from lead, okay, all the way to copper, yeah, actually all the way to mercury, but I did not include mercury here. So from lead all the way to copper, it will just react, but not burn. So it will react but not burn. And finally, silver and gold, they will simply not react with oxygen, no matter how long you wait. So we have three different, tiers of metals. Okay, so the top tier, the tier on top, they react and burn. So the middle tier, from lead to copper, okay, they only react but they do not burn. Okay, you will see it changing color, so that's a sign of reaction happening, but you will not see a flame there. Finally, for silver and gold, they do not react or burn. Okay, so do not react or burn. It is as if nothing happened when you heat them very strongly. Okay, they don't change color, they don't burn, no nothing. Okay, that's the reaction with oxygen. Yeah, and let's take a few examples out and discuss. Okay, in detail. So starting with potassium or maybe sodium. When you heat sodium in the air, you have this reaction. So can you write this down? Sodium plus oxygen will form the compound sodium oxide. So anyone can tell me the formula of sodium oxide, judging from the group number of sodium and oxygen. Sodium is group 1, oxygen is group 6. Now that the test is set tomorrow, you should have revised this already.
Na2O.
Na2O. Okay, so I want other students later to also participate. Okay, so we have Na2O. Write down why. Na is from group 1, so it will be Na1 plus charge. O is from group 6, so it will have O2 minus charge. When you do crisscross rule, you get Na2O1. So you don't write out the 1, right? So it's Na2O. Now, sodium will burn, right? You see, okay, what is the color of the flame due to sodium? Do you remember?
Brick red.
That's calcium.
Oh.
Yeah, so sodium gives a bright yellow or brilliant golden yellow, okay? So you can write down when sodium burns in oxygen, it will form a white oxide, and at the same time it will burn with a yellow flame. So just write down two observations. It will burn with a yellow flame. Brick red is the color of the flame due to calcium, okay, not sodium. So you may also write down that equation because that's what I'm going to ask you next. So when calcium reacts with oxygen, what is the name and the formula of compound? So if sodium reacts with oxygen to form sodium oxide, what do you think calcium reacts with oxygen to give? Calcium oxide. So now that I give you the group number, can you use the group number to determine the charge? If calcium is from group 2, oxygen is from, yes, CaO. Yeah, so why is it not Ca2O2 then? Because whenever possible we simplify, right? Yeah, 2 to 2 can be simplified to 1 and 1. So therefore the formula of calcium oxide is just CaO. Yeah. So normally you don't have to do this all the time. When you're familiar enough, you just remember that calcium oxide is CaO in your head. Okay, just do enough practice. Okay. So what's the color of calcium when it burns? It will give a brick red flame. Okay. So you see, eventually the metal it will turn into some white powder. So eventually it will turn into white powder, both of them. Because sodium oxide is white, calcium oxide is also white. So this is white powder. But the difference between these two metals when they burn is the flame color they give off. So this would give a bright red flame, like in flame test, if you recall. Okay. So now what about a metal that is less reactive, like copper? Okay, so copper is special. While copper compounds, they burn with a bluish green flame. When copper metal burn, they form a black oxide. So this is new. So you may want to put a star here, okay, on the right. So copper oxide. Does anyone remember the ion of copper? Copper does not belong to any main group, so you can only memorize its charge. What is the charge of copper? 2 plus. Okay. So if copper has a 2 plus charge and O continues to have O2 minus charge, what is the formula at the time? CuO. And draw a star like an asterisk on the side. Okay. And write down why I went through that. Most copper compounds are blue or green in color. So most, look at what most, blue or green. But this one, this is a unique one. Copper oxide, I know it contains also copper. Okay, so it doesn't. This rule doesn't apply. Most copper compounds are blue and green. This rule doesn't apply to copper oxide. But copper oxide, you can write down copper 2 oxide is black in color. So this is black. So this is rather unusual. Okay, you can make this an exception. So and copper doesn't burn. Okay, so when you heat copper, it will just turn into a black substance, okay, a black solid. You don't see any flame in here. So that's what sets copper apart from the other metals. So you have calcium here, you have sodium here. So you see those metals at the top here, they will not just react, but they burn. They reacted because they turned into a different substance. From a shiny metal, they turned into white powder. From shiny metal, they turned into white powder. And they also burn, they give a flame. So that's what I mean by react and burn. React means like Ca becoming CO, Na becoming N2O. But here you see I wrote down react but not burn. So there is also a reaction because copper became a new substance. But you don't see a flame. So reaction and burning, they should be considered separately. Okay, they are not the same. Okay. So finally, for silver and gold, if you like, you can write an equation here, but simply there will not be any product. Okay, so you can write down silver plus oxygen. Just write down no reaction. Nothing happens. Okay, if you like, you can still write silver and oxygen on the right. Okay, which means there's no chemical change involved. Okay, so that's with oxygen. Now I want you to let me copy this onto the next page. Now let's take a look at the reaction with water. So the reaction with water is different. Okay, so water, we can use two different types of water: cold water or hot steam. Okay, so first for potassium and like sodium all the way to calcium, these three metals, they react with cold water. Okay, but from magnesium all the way to iron, so magnesium all the way to iron, they have no reaction with cold water. Okay, with cold water. But they do react with hot steam. So no reaction with cold water, but they react with steam. So steam is much hotter than cold water. So if things do not react with cold water, they will probably react with steam. But then they are also very, very stubborn metals down at the bottom, from lead all the way to gold. You can try dropping gold into steam, and it will still not react. That shows you just how unreactive it is. So it has no reaction with both cold water and steam. They are very, very unreactive, that shows. Okay, so cold water and steam. So therefore, on the right, we can summarize it this way. Do they have any reaction with cold H2O? Do they have any reaction with steam? So you can put down, so for cold water, only the first three should you take. Yeah, all the rest here, you put across. Cross, all the way to the bottom. But for steam, if potassium and sodium and calcium, they react with cold water, it will also mean that they also react with steam. Okay, but the other metals, okay, from magnesium, aluminium, okay, zinc, iron, and all the way to iron, they will only react with steam but not with cold water. And then we have the least reactive metals here, okay, that will simply not react at all. Okay, so do you get this table here? Okay, so not just with oxygen, you see a kind of trend, okay, as you move down the series. You see things would react and burn at first, and then they would just react but not burn, and finally they do not react or burn. You can see a trend in reactivity here. Same for the reaction with oxygen. You also see some kind of a trend in reactivity in this part, okay? And we look at how we can react metal with water and steam, okay, on the next page. So how to carry out the experiment. So how to react metal with cold water and steam. Well, with cold water, I'm sure all of you know how to react something with cold water. Just drop the metal in cold water, right? That's easy. But not so much with steam, okay? So draw two setup below. The first setup is when you want to use cold water to react with steam. Okay, so reaction of cold water with metal. The second setup is used for when you want to react steam with metal. So cold water with metal first. Okay, so we look at cold water with metal first. Setup number one here. You just need a beaker, and you will just need a small sample of the metal that you want to test. Okay, so this is the metal, and this is a beaker of water, cold water of course. So you have like cold water in here. You just need to drop the metal in, and that's it. So this is the setup for reacting cold water with metal. Write down the general equation. So you can remember the general equation. So the general equation is that metal plus cold water will give metal hydroxide and hydrogen. Okay, so metal. Does anyone remember the formula of hydroxide ion? Hydroxide ion is a polyatomic ion, meaning it contains more than one atom.
Yes.
So what is the formula of hydroxide? Hydroxide is OH minus. Do you remember the table? Do you all remember learning this on this table? Like many pages ago, at least 10 pages ago, okay, so we came across that table, okay? So that might appear on the test tomorrow. So metal plus cold water will form metal hydroxide. So write down what hydroxide ion means. So hydroxide means OH minus ion. Anything with OH minus ion inside, we call them hydroxide. Okay? Just like anything with O2 minus ion in them, we call them oxide. So things are called differently depending on what they have. And we have also hydrogen gas. So we have also hydrogen gas. So this is why when you actually drop a metal into cold water and it does react, you'll see bubbles. So you'll see bubbles. So let me move this back a little bit here. As I want to show you the observation. When you put the metal in, the metal most likely it will move around. It will move on the surface of the water. And the bubbles, these are actually bubbles of hydrogen. So you have colorless gas bubbles. So note the difference between stating the observation and identifying the product. Okay, because I still see students mixing these two terms up. When you ask to state the observation, what does observation mean? It means what you can see. Can you see hydrogen in this container here? No, you cannot. You can however see colorless gas bubble. So you may want to use two different highlighters for this. This is when you're asked to state the observation. Observation is what you can hear, see, smell, or touch. Okay, so observation is. Can you see the yellow color? Okay, yeah. So it's what you can hear, see, smell, or touch. And when you're asked to identify the product, okay, well, you know that is hydrogen gas. So that's the difference between identifying the product. So identify the product and stating the observation. They are different, you see. So these two things, they are different. Okay? So now, let's try to write a few equations, okay, based on this general equation down below. So remember the top three metals, they react with cold water, right? So they react with cold water. So potassium, sodium, and calcium. So we can write this in here. Yeah, only these three react with cold water. So with potassium, yeah, can you tell me what equation should you write for potassium? Potassium plus cold water, so let's put potassium here. Right, so potassium plus cold water will give which type of hydroxide? Potassium hydroxide, right? So because metal reacts with cold water to form metal hydroxide. So if I swap metal for potassium, you get potassium hydroxide. So what's the formula of potassium hydroxide? Knowing that potassium is from group 1. So potassium, because it's from group 1, it will be K+. Hydroxide ion, because it's OH minus, when you do crisscross rule, what will you get? KOH. Yeah, so can you put that KOH here? And you will have hydrogen. You will have hydrogen. Okay? What about sodium? Okay, so let's try 2 more equations here. What about when you have sodium and cold water? What do they react to give? Sodium hydroxide. Okay, so what's the formula this time? What is the symbol of sodium? Na. Yeah, S is sulfur. Okay, so we have sodium hydroxide. So sodium, because it's also from group 1, it will have this a very similar formula to that of potassium hydroxide. But what is tricky is the calcium one. Okay, so calcium. Can you help me complete this equation here? Calcium plus cold water. What will be formed this time? Calcium hydroxide. But knowing that calcium is from group 2, the formula should be different from that of sodium oxide and potassium oxide. What do you think is the formula this time? So calcium is from group 2. So it should form ions with charge 2 plus. Okay, so what happens when you put a 2 plus charge ion next to a 1 minus charge ion? So you have CaOH2. Yes. So can you put that Ca bracket OH2? So that will be calcium hydroxide. But in all 3 cases, you have sodium. You will have sodium. Okay? I mean, you will have hydrogen. You will have hydrogen. So, and you will get a hydroxide produced. So, what other things should you know? Okay, about this reaction here? Okay, it is that the hydroxide compound, so these are hydroxide, they are alkaline. Do you know what is meant by the term alkaline? Do you know alkaline substances and acidic substances? Yeah, and they are like 2 extremes, okay, of chemicals. So alkaline substances, they have a pH greater than 7, okay? So can you put down also special about this product? These hydroxides are alkaline. So these hydroxides, they are alkaline. Okay, yeah, so can you put this down? These hydroxides, they are alkaline, meaning they will have a pH value above 7. Okay, so and have pH value greater than 7. Do you know how we can tell if something is acidic or basic objectively without tasting it? Is to use some kind of paper strip. What is that paper strip that can change? Yeah, pH paper works. There's another one called litmus. Have you heard of litmus paper before?
Yes.
Yeah, it's either red or blue. It's either red or blue. It is red when it is in acidic solution, and it will turn blue when it is in basic solution. Okay, so put this down. So they can turn red litmus blue. So they can turn red litmus blue. So this is something special about the first product, hydroxide. What about the second product? Also special about hydrogen. What is the hazard associated with hydrogen? What kind of hazard label will you see on a gas tank filled with hydrogen? There's an M word. Okay, so can you write down hydrogen gas? Okay, is flammable. Okay, so hydrogen is flammable, meaning it catches fire easily. So you should avoid, heating sample of hydrogen directly. Yeah, and for potassium and sodium, when they are added to water, they will burn. Okay, just like they will do when you heat it in oxygen. So can you put that for sodium and right? Yeah. So pay attention first. Okay. So we have sodium, we have potassium, and we have calcium. So can you draw three like containers of water here? Okay, so you have cold water in these beakers. Okay, so you have cold water. When you put potassium in, it will explode. Okay, so it will explode, and it will burn with a lilac flame. So you will see a beautiful lilac flame, and that it moves around very rapidly. At the same time, it will release a lot of heat. So lots of heat are produced. So lots of heat produced. And with sodium, it will burn with a, what is the color of the flame due to sodium? Yellow, not red. Okay, so it's yellow. So you will see a yellow flame in here. Less heat will be produced. So if you put a thermometer into the beaker here, you will record a smaller temperature rise. So less heat will be produced. And for calcium, the reaction is even milder. Okay, it will not burn at all this time. Yeah, earlier remember when you heat calcium, it will burn with a brick red flame. Now it won't burn. Okay, but you can see that it also moves right. Okay, so you will see that it also moves around, producing a trail of hydrogen. So this is the difference between potassium with water, between sodium with water, and water, and finally between calcium and water. So can you jot down a few key points in here? For when you add potassium into water, you will see a lilac flame. And also lots of heat will be produced. Remember, observation includes what you can hear, see, smell, or touch, right? So heat is one of the things you can feel. Okay? So lots of heat produced. So lots of heat produced. For sodium and water, you will see a yellow flame. Right? So these are the observation, yellow flame. And you will have less heat produced. So less heat produced, but that's still a lot. Okay? Enough heat is produced to burn the metal. Okay, enough heat is produced to burn the metal. With calcium, even less heat is produced. So little heat is available that the metal doesn't burn. Okay, so therefore you don't see any flame color. Okay, so in case you wonder why will only potassium and sodium burn but not calcium, that's because with calcium you don't even have enough heat to burn the metal. Okay, so even less heat is produced. So the metal doesn't burn to give a flame color, okay? So doesn't burn to give any flame color in this reaction. And the reaction will get even less, so more and more underwhelming, okay, when you look at the metals below calcium. Can you see that below calcium we still have plenty of metals? Magnesium, aluminium, so these metals, they do not react with cold water. Okay, so you can drop a piece of aluminium or magnesium into cold water and they hardly react. But they will start reacting when you expose these metals to steam. So can you turn to another page here and write down the second reaction? The reaction with steam. To react metals with steam, you need a special setup. Okay, so you need a special setup. First, you need to put some wet sand. So this is sand, and this is soaked in water. Okay, it's wet. So you have wet sand. And then you will be heating the metal in here. So you put a lump of metal at this position. And then you can connect a stopper, which is connected to a delivery tube, to a container with water. Yeah, and there is a test tube, okay, put on top of the water. So what is this setup for? This setup is for tracking the gas produced. Okay, because when you imagine that this is not a reaction anymore, but you're blowing air through a drinking straw into this test tube. So where would the gas you blow enter? It will enter the test tube, right? It will enter that inverted test tube. So this inverted test tube is to trap the gas, if you're wondering what it's doing here. Okay? So this test tube. Oh, okay, yeah. Put down this one answer first. I wanted to note down the general equation. So the general equation here is metal plus steam. So where does the steam come from? When you heat the metal, some of the heat will be distributed back into the wet sand here, and it will produce steam. Okay, so the wet sand would evaporate water into the test tube, and then the steam will pass through the metal. Okay, so this is how you make the metal react with steam. So one last thing. Metal plus steam will form metal oxide and hydrogen gas. And where did the hydrogen gas go? The hydrogen gas will then be collected in here and fill up this space. Okay, so this is where you will get, you see the hydrogen gas. Okay, so just a reminder for all of you, like tomorrow we have the test. Okay, on microscopic world 1, microscopic world 1. So book 1. Yes. Yeah. So I'll upload this on okay, and you can refer to that and remember to do it. Okay.